I'm a simple bean, and I don't know why, but when I see melons, there's this ancient neuron in my brain which gets triggered, which makes me go, "Auga, boobies." You know what I mean? It's kind of weird that these round things have such a big impact on a lot of people. And these mighty round milkies are not only present in the real world, but also in our favorite virtual worlds called video games. They come in all shapes and sizes. We have the pixel ones, the ancient Lara Croft pointy ones, hand-drawn ones, and bro, what? These assets have one secret forbidden special move, and I call it the Jiggle. They are present in many great and esteemed games like Genshin Impact, Zenless Zone Zero, and But as a game developer, I was wondering how you can achieve the godly wiggle. So that's what this degenerate video is all about. Buckle up, because we're bouncing right into this topic. Hey, don't look at me, man, you clicked this video. There are two main ways to approach the Jiggle in both 2D and 3D. Let's start off with the simplest one, sweatshops like to call manual labor. This is the most straightforward method of the two, but also the most time intensive, since, you guessed it, you have to do everything by hand. In order to make the boing-boing look realistic in both 2D and 3D, you need to understand the fundamentals of animation, like the principles of squash and stretch, and you need to have a basic understanding of human anatomy. The next step is making the actual animation, which for 2D includes drawing everything frame per frame, which takes ages. Just imagine doing a very difficult task, and then you do it again, but just slightly different, and then you do that 1,000 more times just to create a 5-second animation. Crazy. And on the other hand, the longest task when using 3D is creating the actual model. After that's done, the next step is to rig and weight paint it. This basically means giving your body bones and linking parts of your model to certain bones, so you can start moving it around the way you want. Now, doing it in 3D is in no way easy. If you don't know what you're doing, the animations can look uncanny or robotic, like some Five Nights at Freddy's type shit.
Hop around, hop up, and boogie down.
Which kind of ruins the Jiggle. Now, there are a lot of tricks in order to make the animation process easier and better looking, like playing with the curves or using ease in and ease out to make the movement smooth. And learning all of them takes time, just like learning to draw takes forever. The other approach to the Auga is by doing things procedural. This is mainly for the 3D side of things, but in some cases, the principles go for 2D. Now, an accurate description for procedural goes like this. Procedural is an approach where the result is generated by the user rather than this allows for or in other words, code go brrrr. It can get quite complex and rather boring, which would make this video way too long. So I'm gonna try and break it down for you guys. To explain how we can do this procedurally, we need to know why there are jiggle physics in real life. That is because of this thing called inertia, which is that one thing you heard about in physics class, meaning an object at rest will remain at rest, and an object in motion will continue in motion unless acted upon by an external force. So in our case, we're talking about the melons attached to the body. If the body moves down, the melons will want to stay in place. So they will float there until the body goes too far down, or until gravity does its work.
I hate gravity!
Yeah, me too, CJ. Also known as the external forces. At this point, the melons are moving down. Now, if the body stops moving, the melons will want to continue moving down. But at one point, they can't because they are being held back by our skin. And also, our skin is stretchy, which acts like a spring. And when I translate this to degenerate language, it says, boba go boing boing. Yes. If we want to implement this in a game engine, we just need to make an algorithm which simulates inertia. That's easier said than done, because brother, have you seen physics? Shit's difficult, man. I ain't doing that shit. You thought I was gonna show you how to write the actual algorithm? Bro, you'd have to watch someone who's actually smart. Like this guy, Sebastian Log. He makes good videos, by the way. Luckily for us, there are a bunch of scripts and assets already made for game developers and animators. So we can pull out the big old trick. Your code? No. It's our code, man. Some programs have built-in cloth physics, which could be used for this purpose as well. Whether the asset uses bones or vertex displacement, they all keep track of a few things in order to make it work. Like anchor points to indicate where things are attached to, the base position, the mass, external forces like movement of the character,
Gravity!
Or some external collisions. And most of the time they also throw in the option to set some constraints, so your melons don't do this. The only case when you want this is when you have some weird fetish or you're making Luffy from One Piece. And that, my friends, is a basic explanation of how games make them things do the jiggle. Now, this video was about moving melons, but these principles can also be applied to other things which can jiggle. To give you guys a recent example, in a new and trending Marvel Rivals, one person had the need to make a mod for a certain character called Venom. Yes, ladies and gentlemen, they added a huge horse. Humanity is doomed, boys. Don't worry, the mod is already removed, so you're safe. Okay, and on that note, I guess it's time to end this degenerate video. I just want to add one final big thank you for the support you guys gave me on my previous video. It kind of took off and I didn't expect that to happen, so bless you guys. I'll keep trying my best making these silly little game dev videos for you guys, so. And soon I might even make a project of my own. But anyway, that's it for now. Thanks for watching and beans out.